Hi, I'm Anirudh Ravi, and I'll be explaining a chat application that I developed for my cryptography assignment, along with the crypt analysis of a monoalphabetic cipher that was used for both encryption and decryption of conversations taking place through this chat application. So now we'll run the program. The GUI of the program looks something like this. So this is the listening port onto which the client will be listening for conversations. This is the target port onto which messages will be sent. Then the IP address in this case will be localhost itself because messages are going to be sent within the same system. Now we start up another instance as well. This will be listening to 8878 and the target port will be 8877. In this case also IP address will be localhost itself. Now let's start a conversation. First we listen to both the ports. So the first system, which is Alice, will be listening to 8877 and the second system, which is Bob, will be listening to 8878. Now let me start a conversation. As you can see, along with the plain text, the ciphertext is also included in brackets. Now, if a message is sent from this side, it can be seen over here as well. So the when a message is being sent, encryption is being done, and when a message is received, then decryption is done. In both these cases, a monoalphabetic cipher and a key is used. Now I'll be moving on to cryptanalysis of this monoalphabetic cipher. So for cryptanalysis, I'm going to be using frequency of letters occurring in the English dictionary as a particular feature. So what we'll be using are quadgrams. Quadgrams of a particular word, for example, attack in this case, would be ATTA, TTAC, and TACK. And when we try to find out the probability of attack being an English word, we'll find out probability of its first three quadgrams multiplied with each other. Now, probability of a particular quadgram would be the frequency of that quadgram occurring in the training set divided by the total number of letters in the training set. Now, my training set is this, where the probability of TION occurring would be this particular number divided by total number of quadgrams in the text. So now let us move on to the explanation of the cryptanalysis algorithm. So the cryptanalysis algorithm generates a random key initially and it sets this as the parent key. Then what it does is it finds out the fitness score of the deciphered text using this particular parent key. It then swaps two characters in the parent key and sets this as a child. This child, if it has a fitness score higher than the parent, then this child key is set as a parent key. Now this happens over 1000 iterations. After these 1000 iterations, the best key and the best plaintext are printed out and it moves back to step 1. So every time what it does is it prints out the best key and best plaintext if they happen to be higher than the uh, if they happen to have higher fitness score than the previous key and the previous plaintext. Now let us run the program and see how it works. The program makes use of the PyCipher module and also makes use of the quadgrams.txt which I explained earlier. The quadgrams.txt file is a collection of quadgrams taken from the book War and Peace by Leo Tolstoy. As you can see, this is the ciphertext and it will be finding the best key and best plaintext for this particular ciphertext. So the fitness score, it runs through multiple iterations, and if that particular iteration happens to have a higher fitness score, then it prints out the particular plain text and the key. As you can see, this is the correct key and the correct plain text that is retrieved. Want to know what it takes to work at NSA? Check back each Monday in May as we explore career options to protecting our nation. So this is the plain text that we received, and this is the corresponding key for this particular ciphertext. So this is the ciphertext. So this is how the particular algorithm works. So I ran this program for ciphertexts of different length, and these are the results that were obtained. So as you can see, if the ciphertext is of length between 100 to 1000, then the decipher time varies. But as the ciphertext size increases above 1000, the decipher time also gradually increases. Now the graph that is obtained from between the time taken and the size of the ciphertext is as shown here. It can also be shown in MATLAB, and the results are here. So as the size of the ciphertext increases, the decipher time also increases. So this is my explanation of the chat application and also the cryptanalysis of the monoalphabetic cipher. Thank you for listening.